effect that comes from making y equals 0. I think this will come out nicer. That's 25, that's 169, so that'll be 104. So x plus 2 equals 12, or x plus 2 equals negative 12. We only want the positive answer, so therefore our y-intercept, which is labelled with a D, is 10. Just checking that answer is sensible. Just checking that that does look like a distance of 13. Yeah, that'll do. So again, my diagram's pretty sloppy because that's way higher than 10. I should have used compass, I keep saying that. Now, so that's what we had to do for part A, was find C and D. In part B, we have to find the area of this triangle here. Now never forget that there's always 3 ways to orient a triangle in order to make it easier to find out the area. I'm currently making this the height and this the base. You could also turn it like that and make that the base and that the height. Often forgotten is that you can turn it like that and make that the base and that the height. And finally, don't forget that you've actually got 2 ways to work out the area of a triangle. There's half base times height, and there's also this trigonometric formula. But as it happens, I'm completely sweet to work out the area of the triangle. It's half the base. My value of C was root 165 plus 5, and my height is 10, so my area of a triangle is that. Okay, question number 9. We've got a circle, centre P, comma Q. This is me writing down the equation of the circle straight away. And radius 25 has it meets the x-axis at negative 7, 0 and 7, 0. There's a famous problem-solving strategy, which is to try and notice what's special about the numbers. I'm immediately fastening on the fact that that and that are just positives and negatives of each other. That's maybe going to help me do this question quickly. So 7, 0, negative 7, 0. I should have been told that Q is positive. Now we're going to find the value of the P and Q. Now because I think the reason why they told us that Q was positive is to help us draw the diagram. The y-coordinate of the centre has to be positive, so therefore the centre needs to be above the x-axis. Now, when I draw this centre, let's say we put it there, where letter O is always used to mark the centre. If I know that that's the centre, and I know that this is equal to this, then you can be sure that that is a right angle, because those three things always go together. You can't have two without the third. If that's the center and that's a right angle, then this and this will be equal. If they're equal and that's a right angle, that will be the center. What I'm doing is just convincing myself that I'm not misleading myself by drawing such a neat diagram as this. So how do I work out P and Q? In other words, what must be the center? Well, P has to be 0 because that is halfway between those. Why don't I call that D? I'll work out that distance. We've been told that this is 25, and that is clearly 7. So I'm just going to use Pythagoras here. 25 squared equals 7 squared plus D squared. This is an example of the finding shape strategy. You always got to be on the lookout for right angle triangles, so you can use Pythagoras. Always be on the lookout to add extra lines, so you can use geometry. And here I found a right angle triangle that I can do Pythagoras on using the circle theorem. The circle theorem, by the way, is called perpendicular bisector through center. So as I said, these three things, you can't have two of those without the third. Okay, so this is 625 minus 49 equals D squared. 625 minus 49 square root of 576. D equals 24. So therefore, don't forget to answer the question after you've done the hard work. The actual question is to find the values of P and Q. So P equals 0 and Q equals 24. Now part B is find the coordinates of the points where the circle meets the y-axis. Okay, well we've now nailed the equation of the circle. It's this. When we meet the y-axis, it's x that it's equal 0. Oops. So y would either be 49, or y could also be -1. Don't forget to answer the question, find the actual coordinates. So the coordinates are 0, 49, that's one intercept, and the other coordinate is 0, -1. Just let's check that the answer is sensible. There's a gap of 50 between those two y-intercepts, which makes sense because the radius was 25. In question 10, our task is to show that that lies inside this circle rather than outside. Now a diagram will certainly help me think about this, but I'm not at all sure it'll be reliable. The radius is the square root of 30, which is certainly not convenient. 5, comma -2 is the center. So square root of 30 is a fair bit less than the square root of 36, which is 6. That's a fair bit more than the square root of 25, which is 5. So the radius of this is about 5.5. Just trying to get a good diagram going. So go 5.5 this way. I've been pretty sloppy with some of my diagrams doing this exercise, but in this case, because I'm not really sure what there's no way, even if I had a compass, there's no way I would trust my diagram on this. Our job is to show that 0, 0 is inside this circle, and actually my diagram's showing that it's outside by a whisker. I'll just zoom in for you there to convince you of that. So how on earth am I going to show that how on earth am I going to show that 0, 0 is inside rather than outside? Well, let's just do Dear Mr. Examiner. Let's show off a skill. Let's work out the distance from there to there. The distance is the x-coordinates subtracted and squared plus the y-coordinates subtracted and squared. I've been a bit sloppy there about which was first and which was second, but it doesn't matter when you're subtracting and squaring. So that's the square root of 29. And the radius is the square root of 30. So therefore it must be inside. You just say square root of 29 is less than square root of 30. Therefore 0, 0 is inside circle. Because what I'm saying is that the journey from 0 to 0, from the center to 0, 0, is less than the length of the journey from the center to the radius. So in fact the accurate diagram would have gone a bit further around like that. Question 11. Question 11. We're given 4 points, 3 points, and we're told they lie in a circle. 3 points always lie in a circle. You can always fit a circle through 3 points, no matter what they are. When you look at some of these videos, in retrospect, you might think that my drawing a diagram was unnecessary, but you can't know that in advance. Drawing diagrams is extremely advisable for these. Also, sometimes you look back and think that your diagram didn't need to be nearly as neat as it was, but you can't know that in advance. That's one argument for doing a lot of practice, is it gives you a bit of a sense about whether a diagram will need to be accurate or not. So there's comma A, the circle goes through that. 4, 8 is point B, the circle goes through that. I'm always a fan of having as much detail onto the diagram as possible. I'm always drawing these coordinates on it so that I can look at the diagram rather than having to keep back looking at the text of the question. And 6, 0. Okay. This will be a bit embarrassing. Oh, yeah, that's pretty bad. Anyway, that's my circle. I'm not sure what I would have done if I'd had a compass. Not sure I could have done that any better if I'd had a compass. because I wouldn't have known where to put the center. I mean, if I was really trying to make a really fancy diagram, I could have done a perpendicular bisector of this. That wouldn't have been that hard. The center definitely needs to be somewhere on that line. Then I could have done a perpendicular bisector of this. Because remember, perpendicular bisectors always go through the center. So yeah, I could have used a compass there. Okay, so what do I actually have to do? Find the equation of the perpendicular bisector of AB. AB. So this is the join AB. This is the perpendicular bisector. Okay, so equation for that, template. We need a point that it goes through. The point it goes through is the midpoint of those. The midpoint comes from adding up the x coordinates and dividing by 2. Sorry, that's negative 4, 0, I think. Yep. Adding up them and dividing by 2 gives you 0. Adding up the y coordinates and dividing by 2 gives you 4. And the gradient, let's use this formula. Second y minus first y, second x minus first x. You really do need to be sure in your head in advance what